Every single day, over $57 million worth of granite is ripped from the earth. That's enough stone to rebuild the Roman Colosseum nearly 3 times over. Granite is everywhere, beneath your feet on city sidewalks, inside your kitchen as countertops, and across towering skyscrapers and ancient monuments. It's nature's concrete, forged over millions of years. It's also one of the most durable and prized building materials in human history, used in everything from the Great Pyramids to Mount Rushmore. But how does raw mountain stone transform into precision-cut slabs shipped around the world? From explosive extraction to robotic polishing, this is how over $57 million of granite is mined each day in modern quarries. Granite doesn't form in veins or streaks. It's born deep underground, in massive batholiths of cooled magma. These solidified chambers can stretch for hundreds of square miles, often forming the geological backbone of mountain ranges. To find them, geological surveys use ground-penetrating radar, satellite imaging, and core drilling. They're looking for granite that's not just plentiful, but pure, free from large cracks, discoloration, or internal faults. Only 10 to 15% of granite deposits are considered premium grade. Once a site is chosen, it can take months to prep, clearing vegetation, leveling land, and building access roads strong enough to support 80-ton machinery. In top-producing countries like India, Brazil, China, and the US, quarries are often positioned near ports to streamline global shipping. Some quarry sites have been operational for over 100 years, continuously supplying global markets. Mining begins with precision. Diamond-tipped drills punch rows of holes along a desired block line, each hole as deep as 20 feet. Next, diamond wire saws snake through these holes, guided by pulleys and motors that create smooth, continuous cuts. The wire spins at 25 to 30 meters per second, its diamond segments grinding away even the hardest granite. These wires can stretch over 300 feet long and cost thousands to replace. In tougher areas, microblasting, controlled, low-impact charges, splits the rock cleanly along fault lines without shattering it. The goal: extract a block the size of a small car without any internal fractures. Some quarries even work around the clock in shifts, cutting up to 1,000 tons of granite every 24 hours. That's equivalent to laying 1.5 miles of sidewalk daily. Each day, a large quarry may cut and move 200 to 300 blocks, with a combined weight of 20,000 metric tons. That's enough stone to build a 2-story building every 24 hours. The noise and dust are managed with advanced ventilation systems, mist cannons, and scheduling that limits work during high wind periods. This ensures the surrounding environment and nearby communities aren't overwhelmed by constant disruption. These raw blocks, often 10 feet long and weighing up to 40 tons, are hoisted using massive chain cranes and front loaders. The surface is often rough, coated in dust and oxide. Before they leave the quarry, blocks are inspected for flaws. Large cracks, inconsistent veining, or hidden pockets of mica can downgrade an entire piece. Some quarries use ultrasound scanning to detect internal fractures invisible to the naked eye. The highest grade blocks, those with consistent color and grain, are painted with ID numbers and tagged for export. Just one top-tier block can fetch $10,000 to $50,000, depending on rarity and origin. Lesser-grade blocks aren't discarded. They're often turned into tiles, pavers, or architectural blocks for roads, bridges, and industrial uses. Every part of the stone finds a second life. Next, it's off to processing plants. These facilities can be hundreds or thousands of miles away. That means loading each block onto custom-built flatbed trailers or container ships. A single 20-foot shipping container often carries just 2 or 3 granite blocks, but the value inside can exceed $100,000. From Brazil to Italy, from India to the US, granite travels global highways. China alone imports over 3 million metric tons annually. The port of Xiamen in China is one of the world's largest granite import terminals, processing hundreds of shipments per month. By the time a block reaches the factory, it's journeyed across oceans and continents, passing through multiple customs and handling checkpoints. In Europe, Italy's city of Carrara is not only a granite processing hub, it's also the birthplace of Michelangelo's favorite marble, illustrating how these supply chains have historical roots that stretch back centuries. At the plant, massive gang saws get to work. Think of them as stone guillotines the size of a garage, fitted with 100 steel blades that oscillate through the granite over 3 to 5 days. Water is constantly sprayed to cool blades and reduce silica dust, a major health hazard if not properly managed. Each cut creates slabs 2 to 3 centimeters thick, which are then carried by vacuum lifters to polishing lines. The polishing machines use diamond abrasives in stages, starting with rough 50 grit wheels and ending at ultra-fine 3,000 grit pads. This is what gives granite its iconic reflective sheen. Some slabs are heat-treated to create a flamed surface, ideal for outdoor walkways. Others are honed, leathered, or brushed, depending on client needs. The entire line is automated, capable of processing up to 5,000 square feet per day in a single facility. That's enough to cover 40 average-sized kitchens daily. Larger facilities have multiple production lines running in tandem, ensuring they can fulfill bulk orders for hotel chains, corporate buildings, and high-end residential developments. Even the finest granite has microscopic pores and fissures. To fix this, slabs go through resin treatment. Epoxy resin is spread across the surface and cured in large infrared ovens. This process strengthens the slab and makes it easier to clean and polish later. High-end slabs may go through this process twice, with final hand polishing to ensure a flawless finish. Once cured, slabs are polished one final time and inspected by quality control. Every square inch is examined before it moves on. Color matching and surface consistency are critical, especially for large architectural projects. Some factories use AI-driven visual scanners to detect even the slightest variations. At this point, slabs are graded and shipped to fabricators. These are the companies that turn raw slabs into countertops, wall panels, tiles, or monuments. Using CNC routers, water jet cutters, and laser-guided systems, fabricators cut sinkholes, bevel edges, and even engrave names into granite. This stage adds thousands in value. A $1,500 slab can become a $5,000 countertop after cutting, edging, and finishing. In commercial projects, hundreds of customized granite panels are mounted onto building facades, often using invisible anchoring systems that make them appear to float. Some installations, like the Vietnam Veterans Memorial, require custom-carved inscriptions etched into black granite with surgical precision. Fabrication also includes sealing the granite to prevent staining, using special chemical coatings that enhance durability while preserving its natural appearance. Finished pieces are packed in wooden crates, cushioned with foam and plastic. Then, they're loaded onto trucks for final delivery. Whether it's headed to a luxury kitchen in Manhattan or a city plaza in Singapore, each piece of granite tells a story, one that began millions of years ago beneath the earth. Installation teams use suction lifts and leveling lasers to place countertops with millimeter precision. Outdoor installations can require cranes and heavy-duty scaffolding. Some slabs are installed in public plazas, historic buildings, or luxury skyscrapers, often designed to last for generations with minimal maintenance. In earthquake zones, special flexible adhesive systems are used to mount granite safely without compromising aesthetics. Granite doesn't biodegrade, so what happens to offcuts, broken slabs, or failed blocks? Many quarries now crush waste granite into aggregate for construction, or grind it into granite dust used in landscaping and soil conditioning. Some even sell reclaimed granite blocks as eco-friendly building materials. It's part of a growing push towards sustainable mining. Even granite slurry, the byproduct of sawing, is filtered, dried, and reused as industrial filler or cement additive. Some quarries recycle up to 90% of their water to reduce environmental impact. In certain regions, leftover granite is used in art installations, retaining walls, or even handcrafted furniture. It's a zero-waste goal that's steadily gaining momentum. Right now, the world produces over 140 million metric tons of granite each year. That's enough to pave a 4-lane highway around the entire Earth, twice. Granite mining supports millions of jobs worldwide, from quarry engineers to finish polishers. In India alone, the industry employs over 2 million people, from ancient temples in Egypt to modern skyscrapers in Dubai. Granite bridges, time, style, and culture. It doesn't rust, it doesn't burn, it barely wears. It's fireproof, acid-resistant, and nearly impossible to scratch. That's why it's the stone of choice for both countertops and cathedrals. Granite has been trusted for thousands of years, and with today's technology, it's being used more creatively and sustainably than ever before. And that's how over $57 million worth of granite is mined every day. From blasting bedrock to buffing countertops, it's a global process of precision, power, and patience. Granite isn't just a rock, it's Earth's legacy and humanity's canvas. It's in your kitchen, it's in your town square, it may even be in the gravestone of a loved one. If you found this journey fascinating, hit like, subscribe, and drop your suggestions for what we should uncover next. Thanks for watching.